The cosmos is filled with wonders that are beyond our wildest imaginations. From the fiery explosions of stars to the quiet beauty of distant galaxies, space never fails to astonish. In 2024, the Chandra X-ray Observatory will mark a remarkable milestone, its 25th anniversary. Over the past quarter-century, this powerful telescope has unveiled some of the most incredible images ever captured, offering us a glimpse into the mysteries of the universe. To celebrate this achievement, NASA has released 25 of the most awe-inspiring pictures taken by Chandra. These images not only showcase the raw beauty of space but also deepen our understanding of the forces that shape the universe. The Chandra X-ray Observatory has truly revolutionized our knowledge of the cosmos, allowing us to peer into distant galaxies, nebulae, and remnants of cosmic explosions like never before. As we venture through the remarkable journey that Chandra's images have taken us on, we'll witness the raw beauty of the universe, beauty that's been hidden from human eyes for eons. The power of X-ray imagery has allowed scientists to study the most extreme and hidden corners of the universe, from the death throes of stars to the birth of new celestial bodies. The images reveal a world that is dynamic, ever-changing, and full of explosive energy. Let's take a step back and appreciate the vastness of space, through the lens of one of the most powerful telescopes humanity has ever sent into orbit. We begin our cosmic journey with one of the most intriguing galaxies known to astronomers, ARP-220. This ultraluminous infrared galaxy was born from the collision of two galaxies, an event that sparked a dramatic burst of star formation. The collision created an environment filled with gas and dust that blocked much of the light from the galaxy's stars. However, Chandra's X-ray vision managed to cut through the dense veil of gas, revealing over 200 massive star clusters within ARP-220. The extreme conditions in this galaxy provide astronomers with valuable insights into the behavior of galactic centers during galactic collisions. What makes ARP-220 particularly fascinating is its intense activity and its role as one of the most powerful radio sources in the sky. It's a glimpse into the chaotic aftermath of a galactic collision, showing us how galaxies evolve when they merge and how stars are formed in the most extreme conditions imaginable. Next, we travel to one of the most iconic structures in space, the Pillars of Creation. This image, captured by the Chandra X-ray Observatory, offers a new perspective on this famous feature in the Eagle Nebula, which was first seen by the Hubble Space Telescope. The pillars are made up of cold gas and dust where new stars are being born. The intense ultraviolet radiation from the newborn stars causes the gas and dust to glow, creating the iconic column-like structures. Chandra's X-ray observations provide a deeper understanding of the processes happening within these pillars. These images allow us to witness the dynamic and often violent processes that lead to the formation of new stars, as well as the interplay between radiation, gas, and dust in these stellar nurseries. We continue our journey with the stunning image of NGC 3532, also known as the Wishbone Cluster or Football Cluster, which is located about 1,300 light-years away in the constellation Carina. This open star cluster is home to hundreds of blue and yellow stars, many of which are just a few 100 million years old. It's a young cluster, and Chandra's X-ray images show us the immense energy being emitted by the stars as they go through their early stages of evolution. The cluster is particularly popular among amateur astronomers because it's visible to the naked eye and can be easily observed with small telescopes. NGC 3532 was also the first object captured by the Hubble Space Telescope after its launch in 1990, marking a significant milestone in the exploration of deep space. Moving farther into the universe, we come across one of the largest galaxies known to humankind, NGC 6872. This massive spiral galaxy is located in the Peacock cluster and spans more than 500,000 light-years across. Its enormous size is truly staggering, but what makes it even more fascinating is its unusual shape. NGC 6872 appears to be bent, likely due to gravitational interactions with a neighboring galaxy, IC 4970. As the two galaxies approach each other, the gravitational forces distort the shape of NGC 6872, stretching its spiral arms into an elongated, curving form. Chandra's X-ray images show the incredible energy and activity taking place in this galaxy, providing a glimpse into the complex interactions that shape galaxies and the forces at work when galaxies collide. As we continue our exploration of the universe, we encounter NGC 1850, a globular cluster located in the Large Magellanic Cloud, one of our galaxy's satellite galaxies. NGC 1850 is about 160,000 light-years from the outer reaches of the Milky Way, and what makes it so surprising is that it contains young stars. Typically, globular clusters are composed of older stars, so finding a globular cluster with young stars challenges previous assumptions about how these clusters form. Scientists suspect that NGC 1850 was formed by a massive burst of star formation, an event that likely occurred in the distant past. The discovery of young stars in this cluster offers a fresh perspective on the processes that govern the formation and evolution of star clusters. Moving on to one of the most famous remnants of a cosmic explosion, we come to the Crab Nebula. This is the remnant of a supernova explosion that was observed by Chinese astronomers in the year 1054. Located in the constellation Taurus, the Crab Nebula consists of an intricate structure of gas and dust, and at its center lies the Crab pulsar, a rapidly rotating neutron star that emits intense high-energy radiation. The Crab Nebula is a treasure trove for researchers studying pulsars and the physics of supernova remnants. It's a shining example of the violent end of a massive star's life and a perfect laboratory for understanding the behavior of neutron stars and the extreme conditions that exist in the aftermath of a supernova. Another incredible cosmic explosion remnant captured by Chandra is MSH 15-52. This supernova remnant, located in the constellation Norma, is home to one of the most powerful X-ray sources in the sky, a pulsar known as PSRB 509D58. Just like the Crab Nebula, this remnant provides valuable insights into the nature of pulsars and the aftermath of supernova explosions. Pulsars are incredibly dense and compact objects that emit intense beams of radiation, and their study has revealed a wealth of information about the fundamental laws of physics. By observing remnants like MSH 15-52, scientists can learn more about the role that pulsars play in the evolution of supernova remnants and the behavior of matter under extreme conditions. One of the most exciting discoveries made by Chandra is the observation of a massive galaxy cluster known as AEL 2125. This enormous cluster is located about 3 billion light-years away and is filled with galaxies interacting in a dense, chaotic environment. The sheer size of this cluster, combined with the fact that it's a hotbed of galactic collisions, makes it a crucial location for astronomers studying the evolution of galaxy clusters and the interactions between galaxies. Chandra's ability to penetrate the thick gas clouds surrounding the cluster has provided us with a unique view of this distant structure, allowing researchers to observe the ongoing processes that shape galaxies and clusters on cosmic scales. No discussion of the wonders of space would be complete without mentioning the Virgo cluster. This massive collection of galaxies, located about 50 million light-years away, is the closest large galaxy cluster to the Milky Way. The Virgo cluster contains around 1,300 to 2,000 galaxies, including a large number of spiral and elliptical galaxies. The cluster's gravitational pull has a profound impact on the evolution of the galaxies within it, influencing their shape, size, and movement. Chandra's X-ray images reveal the intricate details of this cluster, shedding light on the complex interactions that occur within such a large-scale structure and providing valuable information about the distribution of mass throughout the universe. Another stunning image captured by Chandra is of NGC 3324, also known as the Gabriela Mistral cloud. This emission nebula, located in the Carina constellation, is illuminated by the radiation from hot, young stars. The gas and dust in the cloud glow brightly, creating a stunning display of colors. What makes NGC 3324 particularly interesting is the way it appears to form a human-like profile, which is how it got its name. The nebula is a site of intense star formation, and Chandra's observations allow us to study the processes that lead to the birth of stars and the ways in which massive stars shape their environment. This nebula is just one example of the breathtaking beauty and complexity of star-forming regions in the universe. As we move through space, we encounter the Snake Nebula, a dark cloud of gas and dust that blocks the light from the stars behind it. This nebula, located in the constellation Ophiuchus, is home to a number of young protostars, stars that are in the very early stages of their formation. The Snake Nebula is an excellent example of how gravity and gas density interact to kickstart the star formation process. By studying these types of nebulae, scientists can learn more about how stars are born and the conditions necessary for star formation to occur. One of the most notable supernova remnants in recent years is SN 1987A, which was discovered in the Large Magellanic Cloud in 1987. This supernova is the closest and brightest explosion of modern times, and it marked the first time that scientists were able to study the entire life cycle of a supernova in detail. The explosion of SN 1987A continues to provide valuable insights into the death of massive stars and the processes that follow the explosion. Chandra's observations of this remnant have allowed scientists to track the movement of the supernova's expanding shockwave and study the behavior of the material ejected during the explosion. SN 1987A remains a key object for astronomers studying the evolution of stars and the dynamics of supernovae. Lastly, we find ourselves in the presence of a galaxy known as the Coma Cluster. Located around 320 million light-years away, this enormous collection of galaxies is a powerful example of how gravity shapes the universe on the largest scales. The Coma Cluster contains hundreds of galaxies, each contributing to the cluster's immense gravitational pull. Chandra's X-ray images of the Coma Cluster have provided a detailed view of the hot gas that permeates the cluster, revealing a wealth of information about the large-scale structure of the universe and the forces at play on the grandest scales. These observations have proven crucial in understanding the nature of galaxy clusters, the dark matter that exists within them, and the larger cosmic structures that form the backbone of the universe. Through these breathtaking images, Chandra has shown us a universe that is dynamic, ever-changing, and filled with wonder. Its observations continue to push the boundaries of human knowledge, shedding light on the most extreme environments in the cosmos and offering us a glimpse into the future of space exploration. Whether it's the aftermath of supernovae, the birth of new stars, or the formation of galaxies, the images captured by Chandra reveal a universe that is far more complex and fascinating than we could ever have imagined.